So next part of dual nature of radiation and matter. In previous part, we have solved up to question number 24, right? So next is 25. This is your part 4 of dual nature of radiation and matter. Dual nature of radiation and matter. So 25 question is photoelectric emission occur only when the incident light has more than a certain minimum, right? So option is power, intensity, wavelength, frequency. Asked in 2011. Photoelectric emission occurs. Required condition is frequency which is falling on the metal should be greater than mu naught, right? So yesterday I have told about it. So falling down the energy equal to h mu. This is your mu naught. So this mu should be greater than mu naught for electron to be come out. That will equal to mv square. So this will be the kinetic energy for electron. Understood? Asked in 2011. Done? Hello?
1 minute, sir.
This question is 26. In the Division and German experiment, name is Division and German experiment, velocity of electron emitted from the electron gun can be increased by. So it is talking about how to increase the electron velocity in the Division and German experiment. Describe that velocity of electron emitted from electron gun increases by using potential difference between anode and filament. So that is a setup. So how you increase the velocity of electron? It is directly proportional to potential difference applied on it. So remember this conclusion only. By increasing the potential difference. VD means potential difference. Asked in 2011. Next question is 27. 27 is asked in 2011 AIPMT. So light of two different frequency whose photon has energy is given. That is E1 is 1 electron volt and E2 is 2.5 electron volt. Respectively illuminate a metal surface whose work function is given. This I have solved now. 0.5 electron volt is given. That is phi naught. For the two. Ratio of maximum speed. It is, we have solved, right? 1:2. Same question asked in 2011. Now, previous one we have solved now, like this same question. That is 21. It is similar to 21. So, for this, watch the previous video, part 3. Next question is 28. In photoelectric emission process from metal of work function 1.5 electron volt. Metal work function is given, right? That is phi is 1.8 electron volt. Kinetic energy of most energy emitted is. So here electron is coming out whose energy value is 0.5 electron volt. Corresponding stopping potential. You have to find the stopping potential. Stopping potential. We have to find it. Asked in 2011. So stopping potential is nothing but maximum kinetic energy. So it is given that 0.5. So it is equal to 0.5. It is direct question only. So remember this relation, maximum kinetic energy is equal to stopping potential. This relation is important.
Done, sir.
Okay, okay. Now look at the next one, 29. 29 is talking about potential difference that must be applied to stop the fastest photon emitted by nickel surface having one work function. This is your work function value is given 5.01 electron volt 5. When the ultraviolet light of 200 nanometer falls on it. So energy whose wavelength is falling down is given, that is 200 nanometer. So how energy frequency is related? Everything is related. Lambda is, if lambda is there, frequency is there. Frequency is there, then energy is there. So this is the Ponent equation. So when lambda is given, you can find the energy also. So you have to just find the potential difference that must be supplied to stop that one. So I will write the Einstein equation. So it will be initial kinetic energy equal to phi naught plus maximum kinetic energy, that is final. So EI we can find, right? So how much it will be? Question number is 29, no? 29. Asked in 2010. So you have to find this value initial. So it will be pi value that is given 5.01 now. Right. So you have to just stopping potential. So it will be pi naught plus kinetic energy will be, this is given, that is 5.01 electron volt. And this will be E equal to SC by lambda. Lambda value we know how much it is, 200. Nano means 10 raised to minus 9 meter. And H value we know, right? So it is how much? 6.626 10 raised to minus 34 into C value is 3 into 10 raised to 8 meter per second is equal to, I will write phi naught as H mu naught plus 5 electron volt. So how much it is now? 5.01. So this will be coming out as 12400 divided by 2000. So it will be 6.2 electron volt is equal to H mu naught plus 5.01 electron volt. So H mu equal to 6.2 electron volt minus 5.01 electron volt. So H mu equal to 1.20 electron volt. This is converted into electron volt, so no need of H. It is divided already. Check this one. We have converted H into electron volt. So mu frequency will be 1.20 electron volt. Next time is 30. So 30 is asked in 2009. The number of photoelectron emitted for light of frequency mu higher than threshold frequency is proportional to. So number of photoelectrons emitted, right? So this frequency of energy is following down on this metal pi naught. Electron is coming out whose kinetic energy is 1/2 mv square. So number of photons, so it is suppose n number of photon is coming out whose kinetic energy will be 1/2 mv square into n. It is asked that number of photoelectrons emitted for frequency mu is proportional to. You have to just relate it. So as we know the relation between saturation current and intensity. So write this statement: saturation current is directly proportional to intensity. It is noted that number of photoelectrons emitted is independent of frequency. Next point, write down number of photoelectron emitted is independent of frequency. Independent of frequency. Right? While it depends on the intensity. Next point, write it down. Number of photons depends on intensity. So more the number of intensity, more the number of photon, but it is independent of the frequency. So these are the 3 points. You should remember it. Asked in 2009. Intensity of light. So question is frequency is directly proportional to number of intensity or its intensity. Write this point. Next question is 31. Monochromatic light of wavelength is given. That is lambda is 667 nanometer. Is produced by helium neon laser. So it is produced by helium neon laser. The power emitted is how much power it is producing? That is equal to 9 milliwatt. M for milli. The number of photons arriving per second. So you have to find number of photons per second on the average at a target irradiated by this beam. As we know, energy formula is E equal to H mu. After putting mu value C by lambda, and we have it will be E, and power is defined as power is nothing but energy upon time. So it will be how much? SC by lambda into T. And when it is talking about photons, so multiply with N. So number of photon per second will be how much? N upon 2 is equal to P into lambda by HC now. Lambda value we know, right? And power we also know. So power is 9 into 10 raised to minus 3 millimins. Lambda convert into meter, so it will be 667 into 10 raised to minus 9 meter. 667 into 10 raised to minus 9 divided by H Planck constant we know 6.67 10 raised to minus 34, and speed of light is also known V into 10 raised to 8. Calculate this data, then you will be getting N upon T, right, as 3 into 10 raised to 16. So this will be the value for photon per second. Write it down. In the similar question we have done the same question in the previous. So it is asked in 2009. So remember this formula. This is energy formula. This is your power. P4 power, and it is nothing but work by time. So this is your work by P4 time. It can be converted into energy also. The power is also defined by energy upon time. Now 32nd question is photoelectric threshold wavelength for potassium is. So you have to find lambda naught. Lambda naught is also known as threshold wavelength. Threshold wavelength. So it is talking about potassium. Potassium symbol is K, whose work function is given. Phi of K is given. That is 2 electron volt. Asked in 2001. 32 number. So we will use the same formula for finding the threshold frequency. E equal to, we know that is how much? E equal to S H mu, right? E equal to H mu, or it can be written as SC by lambda. So mu naught value we know, right? Let's see, na? So next question is given 32. Question is photoelectric threshold wavelength for potassium. You have to find threshold wavelength, that is lambda naught. You have to just find it of energy. Work function is given pi naught, that is 2 electron volt. It means E naught is given. Understood? So we will use the next formula, energy formula. So it will be E naught equal to H C by lambda naught. So you have to find lambda naught. So it will be equal to SC upon E naught. H, when we multiply H into C, so multiplication of this is to be remembered. So it will be how much? 12400 electron volt. And this is also is electron volt. That is 2 electron volt energy. Initial value we know, and multiplication of this is equal to 12400 electron volt. Remember this value. So H is nothing but it is Planck's constant, and C is the speed of light. Speed of light. After solving, you are getting how much it is? 6200. So this much of Armstrong lambda threshold wavelength is there. And as we know, one A naught is 10 raised to minus 10 meter. Write the value here. You will get 6200 into 10 raised to minus of 10. So it will be cancelled. It will be minus of 8. Convert into 10 raised to minus 9. So what we have to do? Just multiply it by 10 and divide it by 10. Then you will get 10 raised to minus 8. After solving these two, it will be how much? 620 into 10 raised to minus 9 is equal to threshold wavelength. Then it will be 620, and as we know 10 raised to minus 9 is called as nanometer. N for nanometer. This is your threshold wavelength. Write it down first. Once again. Now see the 33. 33 is asked in 2004. work function of metal is given. Phi naught is given, that is 4.2 electron volt. Threshold wavelength you have to find it, means lambda naught. So use the energy formula directly, you will get it. Phi naught we know, right? So E naught is equal to Hc by lambda naught. So you have to find lambda naught. So it will be Hc by E naught. Hc by lambda naught is nothing but it is phi naught only. We know the value Hc 12400 electron volt, and phi naught is also given in electron volt. So this will be cancelled. Remove this point, so you will get 10 here. Now solve. How much you are getting? Solve it by 2 then. It will be 2 1. It will be 6 2 0 0. 433 now. So you get in the point form like it will be 2955 into 10 raised to minus of 10 Armstrong. So convert into meter. So it will be how much? 2955 Armstrong. Write it down there. So this will be the threshold wavelength. Asked in 2001 now. 2004. Asked in 2004. Next is 35. De Broglie wavelength is lambda associated with electron having kinetic energy E. This is kinetic energy is given by, तो बहुत सिंपल है, डायरेक्ट फॉर्मूला है, 1996 में पूछा है. तो लैम्डा इक्वल टू क्या होता है? लैम्डा इक्वल टू H अपॉन P होता है. सो यू कैन राइट P एज अंडर रूट ऑफ 2m E ना kinetic energy. So this is the relation between lambda and kinetic energy. They are inversely proportional to the square root. Write it down. Asked in 1996. Then try to solve next one.